Hi, this is going to be notes for 5.1, which is about composite functions. So, composite functions are when you put one function inside another. It's very similar to plugging in a number into a function, except you're putting a whole nother function in there. So one way to write it is with this little circle. So the way you would say this is f of g, and this means the exact same way. So these are two different ways to mean the same thing. So they basically mean you're going to do the composition of f and g. So the way it's written, you're always putting the second function inside the first. So let's try some. So f of g here means put the g function inside the f. So really, you start with the first function and do that. Wherever the x was, and if there's more than one x, you'll do this more than once, you leave a space. And so now what are we putting in that space? The g. So in this problem, g is 8x. So that is it. But then you just need to do whatever algebra is necessary to reduce that or to make it as nice as possible. So in this case, all we can do is the 2 times the 8x. And you cannot add those. So we are done. So now let's just do the opposite. This time we're putting the f inside the g. So I'm going to start with the g function and leave a space where the x was. And now what am I putting in there? I'm putting the f inside there. So that would be 2x plus 1. This time I can distribute the 8 and it would be 16x plus 8. So sometimes these end up being the same thing, sometimes they don't. So let's try it again. So this is the same thing. Remember, it means to put the g inside the f. So I'm going to start with the f, leave my space, and now what am I putting in there? The g. This time, though, the parentheses don't really matter because there's nothing being multiplied, there's nothing being squared or anything like that. So don't distribute these or multiply these because it doesn't say to do that. So really, all you can do at the end is put them together like that. So I always put those parentheses, but just make sure you notice when sometimes, okay, they really weren't needed, so now I can get rid of them. So this time the f inside the g, so I'm going to start with the g, put my parentheses. So do you see it's just the x that has the space. So if there's a -2 out front, then it needs to be outside of the parentheses, and if there's a square, that needs to be outside the parentheses. So now what am I putting in there? The f, which is x plus 3. So this is a problem a lot of people miss because now they're not sure how to reduce this correctly. Order of operation tells us to square this first, and squaring x plus 3 really means this. So I'm going to save the -2 for last, but right now I need to do this by boiling it out. So I get x squared plus 3x plus 3x plus 9, which is really x squared plus 6x plus 9. But then don't forget, I now need to multiply that by -2. So -2 needs to go to all of those things. So final answer is -2x squared minus 12x minus 18. So definitely make sure you notice how to handle something like this. Okay, so now if you think you understand how to handle it with x's, now what happens if they give you something like f of g of 2? Well, you could do the same thing we just did, and then when you finally get your answer, then you could plug in 2, but there's a faster way. So the same reason we always do the g inside the f, now that we have a number, we're going to, again, work from the inside out. So I'm going to first plug 2 into the g function. So that would give me 2 squared minus 1, which is 3. And now I'm going to take that number and plug it into the f. So we're just working from the inside out. I plugged 2 into g and I got 3. So now I'm going to plug 3 into the f. So my final answer is 7. So if you think you get that, you can pause this and try these, but I'm going to plug -1 into the F. Which gives me -5. So now I'm going to take -5 and plug it into the G. Okay, and then I just gave you an example where it was the same function twice. That doesn't mean to do anything different. Just make sure you're following the direction. So it's telling me to put 0 into the F function. So I got -2, and now I just happen to be plugging -2 back into the F again. Doesn't matter. So plugging -2 into the F function gives me -8. Okay, so that's how to handle if they want you to find an actual value. So now we're going to do the same thing, but we don't have any equations. But if they give us a table with all these values, we just need to carefully go in order. So again, inside out. So what happens if I were to plug 1 into the G? Well, that means the 1 would be our X. So see this chart? These are all the X values. So 1's the X. What happens when I plug it into the G? Apparently, I would get 0. So now, what if 0 was the X that I was plugging in to the F? So if 0 was my X now, and I plugged it into the F, I would get 4. Okay, so let's do that again. If I was plugging 2 into the G, that means I go to 2 and see what it would be for the G of X. Apparently, it would be -2. So now, what if I plugged -2 into the F? So -2 into the F would give me 6. So again, if you think you get this, I would pause and try the next two and then see how you do. Plugging 2 into F would give me 2. So plugging 2 into G gives me -2. Finally, plugging 1 into the G, so +1 into the G gives me 0. And now it doesn't matter if it's still G. I'm just going to do the steps the way I'm supposed to. What if I plugged 0 into G? So go to 0 and plug it into G. Apparently we would get 2. So don't think when you see the same letter that it means it wipes each other out or anything like that. Just do the steps the same way you always do. And now, same type of thing, but instead of giving us a chart, we have a graph. So if they tell us that this one is the f of x and this one is the g of x, we're basically going to do what we just did with the chart, but we're going to have to look on the graph to get the values. So if it's asking me for g of f of -1, I start with plugging in or looking on the graph where x would be -1, look at the f. So -1, if I look at the f, the y value would be 3. So now if I plug in or look on the graph where x is 3 and look at the g function, what do I get? So 1, 2, 3. If I look at the g function, it looks like I get 3. Okay, so when you're plugging in with a graph, it really means this is your x, what would be the y? So starting this next one, if x was 0, what would be the y on the f function? So when x is 0, if I go to the f, do you see that the y value would be 2? So now, if x were 2, what would be the y value on the g? So if x were 2, what would be the y value on the g? 4. Again, maybe pause and try the next one, see if you're getting the hang of this. -1, if I look at the g, So if x was -1 and I look at the g, it looks like it is 5. But now if x were 5 and I look at the f, what would I get? So if x were 5 and I look at the f, it looks like it is -3. Okay, so doing it on a table or graph, exact same process. It's just here they're just giving you the answers, and here you have to look on the graph to get the answers. Okay. Last thing is when you're plugging a function into another function and they ask you for the new domain, there is something you need to be careful about. So when trying to find the domain of a composite function, something like f of g of x, the domain is the domain of g of x, meaning the inside function and the whole thing. So basically, you just have to combine them. So you have to include both restrictions. So if your g of x had something where you knew that you didn't want 2 as an answer, and then when you got this new function, it didn't want 0, then your domain would be everything but 2 and 0. So you just have to make sure you look at both of them, just the inside one and your new answer. So let me show you an example. So if I was doing f of g of x, that means I'm putting the g inside the f. So first on the side, I'm just going to kind of make a little note. The inside function is g, and what would be the domain of g right now? Well, wouldn't our domain be everything but x is 0? So I'm just going to make a little note to myself so I don't forget that my final answer still cannot include 0. So let me find my final answer and then we'll do more. So putting the g inside the f. So there's an x there and there's an x there. So that's me leaving my spaces. And now I'm plugging in my g. This is kind of a mess. So what can I do to make this nicer? Well, if you see that everything has an x on the bottom, you could multiply the top and the bottom by x to make it a little nicer. So if I did that on top, I would end up with just -6. If I did that on the bottom, I would end up with a -6 minus 7x. Because you see, when you multiply this by x, it wipes it out. When I multiply this by x, it wipes it out. But then don't forget, you have to multiply that 7 by the x also. So this is much nicer. So this is my answer. This is my f of g of x. What would be the domain of this, though? Well, we would have to set that denominator equal to 0 and see what would do that. So I would add 6 and divide by -7. So apparently I don't want, right, because it's my domain, I don't want -6/7. So my domain is everything but the -6/7, but also don't forget that we also don't want 0 because we have to include anything we didn't want from the inside function. Okay, let's try another one. What if this time they wanted us to put the f inside the g? Well, that would mean f is our inside function. So off on the side, I'm going to make a note on what the domain of f would be. So looking up here, what would be the domain? Well, wouldn't it be everything but 7? So my final answer, I need to make sure I don't include 7. So putting f inside g means coming over to the g and leaving my space, and then plugging in the f. Again, this looks like a mess, so don't forget that if you have a fraction over a fraction, you can rewrite it by saying the top, instead of being divided by this, can be multiplied by the reciprocal. And so that would get us negative 6x plus 42 over x. So this is my new function. And what would be the domain of this function? Everything but 0. So what is the domain of it really? Everything but 0. And don't forget, we also don't want 7 because that was a restriction from the inside function. So that is how you do the domain of a composite function. Hopefully that was helpful. Feel free to contact me if you have any more questions.